Let's recall the exponential function natin, b raised to x. So, ganito yung kanyang itsura whenever b is greater than 1. And ganito naman yung kanyang itsura whenever b is between 0 and 1. Now, to find the limit of exponential functions, basta x approaches a certain number, yung normal lang na limit ang gagamitin natin. So, we just have to substitute the value of x. So, in this case, if we find the limit as x approaches negative 3 of 1 half raised to x, we will just substitute the value of x. So, that is 1 half raised to negative 3, or that is 2 raised to 3. Diba? Kasi nga, magiging 1 half, 1 raised to negative 3 over 2 raised to negative 3 yan. Siyempre, mababaliktad din kasi negative para mag-positive. So, we have 2 raised to 3 over 1 raised to 3. Kaya, naging 2 raised to 3. And that is equal to 8. Second naman, the limit as x approaches 2 of 4 raised to 2x minus 2 times 4 raised to x plus 1. I-substitute lang natin, we have 4 raised to 2 times 2 minus 2 times 4 raised to 2 plus 1. So, that is 256 minus 32 plus 1 or 225. However, kapag yung x natin approaches positive or negative infinity, ibang usapan na yon. And this leads us to our theorem number 1. The limit as x approaches positive infinity of b raised to x is equal to 0 when b is between 0 and 1. And positive infinity when b is greater than 1. And the limit naman as x approaches negative infinity of b raised to x is equal to positive infinity when b is between 0 to 1 and 0 when b is greater than 1. So let's find the limit as x approaches negative infinity of e raised to x. So for our solution, since e is greater than 1, so the limit as x approaches negative infinity of e raised to x is just equal to 0. Let's find the limit as x approaches 0 from the left of e raised to 1 over x. So since 0 naman yon, pwede nating i-substitute. So we have e raised to 1 over 0. The problem is 1 over 0 is undefined. So hindi pwede. So how will we answer that? Okay, so we let m be equal to 1 over x. So, eto yung f of x equals 1 over x. Observe natin, no? As x approaches 0 from the left, yung m natin approaches negative infinity. So, pwede natin ngayon i-substitute yan. So, we have the limit as x approaches 0 from the left of e raised to 1 over x is equal to the limit as m approaches negative infinity of e raised to m. So, pwede nating magamit yung theorem number 1 natin, which is just equal to 0. Let's find the limit as x approaches positive infinity of e raised to negative x. So, we rewrite e raised to negative x as e raised to negative 1 raised to x. And e raised to negative 1 is just equal to 1 over e. Ano ba yung value ng 1 over e? That is just equal to 0.3 something. 3 something yan sa calculator ninyo. Which is less than 1 but greater than 0. We can now use our theorem 1 and that is just equal to 0. And finally, let's find the limit as x approaches positive infinity of 2 times e raised to x over e raised to x minus 5. So for our solution, okay, by direct substitution, that is indeterminate. So anong gagawin natin? We divide everything by e raised to x. So we now have 2 times e raised to x over e raised to x all over e raised to x minus 5 over e raised to x. Paghiwalayin natin yung nasa baba, we have e raised to x over e raised to x minus 5 over e raised to x. So, pwede na natin ngayong i-cancel out ito, tsaka ito, okay, magiging 1 lang yan. So, we have the limit as x approaches positive infinity of 2 over 1 minus 5 over e raised to x. And we know that that is just 2, that is 1, and this is equal to 0. Paano naging 0 ito? Di ba kanina, 1 over e raised to x is just equal to 0. In our example number 4, kaya 5 times 1 over e raised to x is just 5 times 0, kaya 0 yan. or that is now equal to